Hey, what's going on guys? Welcome back to another video. And in this video, we are going to talk about how JavaScript code execution happens. JavaScript being a synchronous, single-threaded language, but still able to perform async tasks. We will see what is blocking and non-blocking code, and how JavaScript runtime engine able to handle async tasks under the hood. And that is the reason we can write very performant applications in JavaScript with less efforts as compared to other languages. So if this sounds interesting, then watch the video till the end. Also make sure you subscribe my channel and press the bell icon so that you don't miss the videos like this one. So let's get started. Alright guys, so first we will try to understand what this synchronous code is and how this synchronous code execution happens. So I'm just going to write some console.log and I'm going to do task 1. Alright, and I will copy this. So I'm going to copy this and I'm going to do here task 2 and task 3. And if I save this, then we will see that the execution will happen sequentially. So first the task 1 will be logged, and then task 2, and then task 3. And that is very obvious. So this is the synchronous execution of the code. One code is executed after line by line. But there are some of the tasks which you see that actually blocks your execution, and such tasks are like if you want to call an API and you never know that how much time the API going to take to respond you back. And in such cases, the execution of the code will stop there itself until you get the data back from the server. And there you can see that there is a blocking code because the execution will halt until you get the response back from the server. So let me create an example which actually shows us the blocking code. So what I'm going to do, I'm going to write a console.log, and I'm going to log here start operation. All right, and then I'm going to write a function sleep, and it's going to take an argument milliseconds. And then I'm going to create a variable start time, and it's going to take the current time. So I'm going to do get time. All right, and then I'm going to create a while loop here. So that while loop will be taking the new date dot get time. All right, and if this time is less than the start time plus the milliseconds which I am going to pass into my function. So I will add that millisecond. And before adding this, what I want, I need to have one more console log here. So I'm going to add a console log here, and I will write here operation is running. All right, and then inside this, I'm going to console dot log in progress, and the last I'm going to console here operation is done. All right, and once this operation is done, then we will do something. So let me console here that do thing else. All right, so now let me walk through this code, what actually we are trying to do. Let me call the sleep here. So I'm going to call the sleep here, and I'm going to pass 1000 milliseconds, which will be the 1 second. So what actually we are going to do here is we are trying to create a delay of execution of our code. So what is going to happen? First, it's going to log the start operation, and then the function sleep will be called. When this function will be called, we are actually taking the time of that part, and after the time this operation is running will get executed, and then this is going to be in a while loop until this condition is satisfied. The execution of the code, which is this console, and the last console, is going to get blocked, and the execution once done, then only the execution of the other code will happen. So let me show you. If I save this, so now if I start, you can see that first we have the start operation, then operation is running, and then it's trying to execute this condition, and it is going to block my execution of the rest of the code until this condition is satisfied. And this is called the synchronous programming, where your code gets blocked until it's get executed, and then the remaining code will get executed. So this is the blocking code. So this can be sometime lead into a bad user experience, because when you do a synchronous code, you cannot write a performant application. Let's understand this with some slides. So when the synchronous code execution happens, what is actually happening under the hood? So under the hood, the JavaScript runtime engine consists of two parts. The first part is the heap, where the memory allocation happens, and the second part is the call stack, which is a single thread which the JavaScript browser has to in order to execute the JavaScript code. So in the call stack, you will see that there will be a global execution context, which is, you can say, as a main method. And we are going to take the same example which we saw in our Visual Studio Code. So you can see that we have the same example here, and the code execution will happen line by line, starting from the first console log, which is the start operation. So the start operation is now coming into the call stack, and then in the call stack, once it get executed, we are going to see it on the console browser. Once it is done, the next step happens is the function call of sleep method. And when the sleep method comes into the call stack, it's going to call the function sleep. And inside the function sleep, we can see that we have a console log, which is the operation is running. So in the next step, what will happen? There will be another stack will be added on the sleep, and that will be the console log operation is running. Once this console log is printed on the console, the next execution will happen for the while condition. So the while condition, it's going to halt our execution until this condition is satisfied. That means the rest of the code execution will be blocked here. So once the condition is satisfied, you will see that the console log in progress is now in the call stack. And once the in progress is logged into the console, the next execution will happen of the operation is done, and that will come into the call stack. And once this is executed, we will see on the console log, and now our sleep method is executed completely, so it will be removed out of the call stack. And in the end, we will have a console log which says do something else, that will get executed, and we'll see it on the console browser. So this is the sequence which we actually saw in our console when we executed the code in the Visual Studio Code. So let's go back to the Visual Studio Code, and then let's try to convert this synchronous code into an asynchronous, and then let's see how actually the JavaScript engine will handle the asynchronous task, because it only has a single thread, which is the call stack. Then how it's going to handle these async tasks, and how it's going to make our code into a non-blocking code execution. So let's get back to the Visual Studio. So now we can see that the same sequence is consoled in the browser. Now let's try to convert this synchronous code into an asynchronous. I'm just going to remove this part, and I will also remove this as well. And what I'm going to add here, I'm going to add a set timeout function which get executed asynchronously. So I'm going to write a set timeout, and the set timeout function actually accepts another function as an argument, and that function is known as the callback. We are not actually going into the deeper part of callback, promises, async, await, which are the way you execute your code in an asynchronous manner. We will be seeing these in the coming videos, but now let's just focus how this execution happens and how this asynchronous task is handled. So I'm going to write a arrow function here, and that arrow function is going to do a console dot log. And now I will just shift this console here, and this execution will happen with some milliseconds or with some delay, which we are going to pass from our sleep function. All right, and now if I save this function, the execution, I just want you to think for some seconds that how this execution sequence will happen. We obviously know that the first execution will be the start operations, then the sleep method will be called, and once the sleep method is called, the browser will execute the console log operation is running, and after that it comes to the set timeout. But this is going to be an asynchronous execution. It will not wait for the 1 second in order to finish this execution of the set timeout. It will just go on to the next statement, which is the console log do something else. And once this is printed, so now if I save it, then you will see that first the start operation happens, then operation is running, and then do something else, and once it is get executed, it actually prints the operation is done. So this is in an asynchronous manner, so it is not waiting for a set timeout to get executed and then goes to the next statement, unlike what we saw in the synchronous, where it actually blocks your execution flow until the condition was matched. So that's the difference between the async and asynchronous. Now let's see actually how this asynchronous thing happens in a single thread, because we only have a call stack. So let me get back to the slides. All right, so now we are back into our slides, and we have the same example which we just saw in our Visual Studio Code, and we have very simple structure. We have a call stack, we have a browser console. So the first thing happens is the start operations comes into the call stack, and after that it get executed. The sleep method is called. Now the sleep method is in our call stack, and after that the console log operation is running, is coming into the call stack, and once this get executed, it gets printed on the console, and then we have the set timeout. And here the CB refers to the callback function, which we pass the arrow function. 1000 is the milliseconds we passed. So what happens actually, the call stack immediately, as soon as it sees that a set timeout is in the call stack, it will just pop out the set timeout, and it actually gives this set timeout to the web API. So the browser already have this web API, a separate thread, which is actually going to execute your async functions like set timeout, set interval, or event listener. So all such callback events or the functions, whenever they enter to a call stack, the call stack actually sends them to a web API for a separate execution thread. So here we can see that the set timeout is in the web API, and next what is going to happen, the do something else will get into the call stack, and once it is printed on the browser, the web API what is going to do is set timeout function will register itself into an event table in the web API. And once it is registered into the event table, the next thing is going to happen is the event table will put this callback function into a task queue. So all the callback functions like the set timeout, set interval, add event listener, or ajax call, so all such asynchronous tasks has a callback function, and that callback function is passed to the task queue. Once it is passed to the task queue, it will wait for the call stack to get empty and all execution gets finished. Now we can see that the call stack is empty. What is going to do? There is a thing called event loop. So all the events from the task queue are now passed to the call stack. And now our execution of the callback function is done by the call stack, and we get printed the operation is done. So this is how the under the hood the async execution happens, because call stack is a single thread, and on a single thread we cannot perform the async task. So that's how we saw how the asynchronous execution happens in JavaScript. So let me get back to the Visual Studio Code. All right, and this is what the sequence we actually saw when our execution happened by the JavaScript runtime. We saw first start operation, then operation is running, do something else, and then we got the operation is done. So that's all we have. We know that how the execution is happening in JavaScript and how JavaScript handles the asynchronous task with a single thread. And I saw a lot of developers whenever you just ask them, is JavaScript a synchronous or an asynchronous, they promptly will answer me that it's an asynchronous. But no, JavaScript is actually a synchronous single threaded language, but you can handle the async task using callback, promises, async await, which we are going to see in the next videos. So I hope you like this video. A thumbs up is appreciated. Also make sure you subscribe my channel and press the bell icon so that you don't miss the videos like this one. You can also connect with me via Facebook or Instagram. I will add the links in the description below. And thank you. Thanks for watching.